Hello everyone, as I promised you, I'm going to do a couple of more exponential equations. If you have other ones, send it to me, and I find it that if those are any different to the ones that I have done, then I will do the videos and I'll upload it up for you guys to have a look at. This equation is slightly different from the ones that I've done before because the base of the exponential is not such that you can make them both the same. So as you look here, 5, for example, can be written as 5 squared. And although 1.4 has got a 5 in it, 1.4 is a 7/5, which is the same as 7 times 5 to the power of -1. So it does have an element of 5 in it, but it also has a 7 in it. And hence we can't make the two sides the same. So I'm going to use the log here. I'm just going to write log, which means log of base 10. Remember one very important rule that I have discussed it with you before, and that is that if the equation has got more than one part to it. So for example, if the equation was made to be, say, a plus b equals c, then you're not allowed to distribute logs amongst this. So you can't write log of a plus log of b is equal to log of c. That's no longer an equation. It's not the equation that it was before. I mean, it is an equation, but it's not an equation that was before. So, so in these situations, you can do log of the whole of the left-hand side is equal to log of the right-hand side. That we can do. And so be careful with that. Thankfully, the equation that we are solving has got one unit on one side and one whole thing, which is the exponential on the right hand side. So I am going to just apply a single log to each side. So that will give me log 25 to the power of 3x minus 2 is equal to log of 1.4 to the power of 2x plus 7. So if you if we do a quick revision or a review of the rules of logs that we know, when you have the subject of log to a power, this is rule number 3. If you have a subject to a power, the power becomes a coefficient. So let's put the rules on the side in case we need them again. So that's the power. So that we don't forget that the power is going to become a coefficient. I'll put it in a bracket, so that would be log 25, and that's equal to, then the power again is written in a bracket, and that's log of 1.4. For simplicity, instead of keeping log 25 as log 25 and log 1.4 as a log, for simplicity, I'm just going to replace this with the letter A and this with letter B. These are numbers, basically. Log 25 is a number. And then I expand that. So, so I expand A into the bracket. So I would get 3ax minus 2a, and that's equal to 2bx plus 7b. Let's group the x's together. So 3ax minus 2bx is equal to 7b plus 2a. And then we unify the x's, and that would mean that we factorize an x, so that would be x 3a minus 2b, which is equal to 7b plus 2a. And then finally we get x by itself, or isolate x. So x would be equal to 7b plus 2a over 3a minus 2b. We can replace the a and b back with what they were. So this would be 7 log 1.4 plus 2 log 25 over 3 log 25 minus 2 log 1.4. And then I suggest you just type that in the calculator and get the answer. Answer to 2 decimal places is what is requested here. You do use the fraction format of entering this information into the calculator. I'm not going to do it because this is not a very difficult thing to do, and you can do it. So I'm going to move on to the next question. The next question, as you can see, has got 2 parts on the right-hand side of the equation. That is, this question is a pseudo quadratic. So let me quickly show you how that works. So on the left-hand side, I've got 4 to the power of x minus 1. I'm going to write that as 2 squared. So 4 is the 2x squared, and that's to the power of x minus 1. And on the other side, I have 2 to the power of x, 2 to the power of x plus 8. So when you bring the power outside the bracket into the bracket, the 2 powers will get multiplied. So therefore, you will have 2 to the power of 2x minus 2. And on this side, you would have 2 to the power of x plus 8. And 8 didn't come out that nice, so I'll just write it again, 8. Yeah. Now that's a subtraction of powers, which basically means that this had been a division. So if you think about it, this has been a 2 to the power of 2x divided by 2 squared, and that's how the powers been ended up being subtracted from one another. And that's basically a quarter. So that's the quarter. So that's the quarter of 2 to the power of 2x. Yeah. So that's what I'm going to write. I'm going to basically write, replace this with a quarter of 2 to the power of 2x, which is equal to 2 to the power of x plus 8. Yeah. Now I'm going to replace 2 to the power of x with another letter. So so let's say let 2 to the power of x to be equal to another letter y. Now, so here, the 2 to the power of 2x can actually be written as 2 to the power of x and then squared. 2 powers outside and inside the bracket will get multiplied. So that this is actually 2 to the power of 2x still. But it's more clear to see that this is y and y being squared. So the equation ends up being a quarter of y squared. And I'm going to bring the rest of them to the left as well. So that will be minus y and then minus 8 equals 0. Straightening this equation, multiplying it throughout by 4, you get y squared minus 4y minus 32 is equal to 0. And that can be factorized. So if I factorize that, I would get y minus 8 and y plus 4 is equal to 0. Yeah. So the two answers are y is equal to 8 or y is equal to -4, and reminding ourselves that y was actually 2 to the power of x is equal to 8, and and 2 to the power of x is equal to -4. 2 to the power of x is equal to -4. Reasonably, if you wanted to solve this, we would have had, perhaps sometimes we would have to use logs again. So, you know, I log this side, I log that side, I log this side, I log that side, and then x becomes a coefficient and solve it. But this one is so obvious because this is actually 2 to the power 3. So 8 is 2 to the power 3. So this equation is so obvious that x is actually 3. So here, x equals 3. It's obvious on the other side also, for this equation, it's obvious that there won't be an answer because if we had to, and sometimes you have to log these to get the answer. So if I had to log it, you can see that if I log the left-hand side, I get log of 2 to the power of x is equal to log of -4. Yeah, and the issue is this side. So although that side will still work perfectly, so x become a coefficient, and this is log 2, but this is log -4, and we don't have a log. We're not allowed a log of a negative number. So if that was okay, if that was a doable thing, then x would have been this log divided by this log, and that's generally how you would solve them if it was doable. But this is not an acceptable answer, so therefore that's actually not a right equation, and that doesn't have an answer. And the only answer to this equation is x equals 3. Yeah, it's another thing to remember is that this is an exponential, and if you remember, I don't want to get into this too much, but if you remember, the graph of 2 to the power of x was actually a curve that did this, and it hit the y-axis here at 1. And so as you can see also here, that 2 to the power of x can never be negative. It's always above the x-axis. It can't ever be negative. So this balance cannot ever happen. This equation cannot ever happen. So therefore, there isn't such an x that can do that for us. Okay, I hope you liked these explanations. As I said, if you have questions regarding any aspects of maths, really, that you have found and you couldn't find resources anywhere else to do it or explain it to you, then send it to me, and I will be too happy to do them and upload them onto my channel for you guys to have a look at. Keep in touch and see you in the next video.